Hello everyone, welcome back to another video, and in this video I'm going to solve problem of the day from leetcode, and its name is capacity to ship packages within D days. I'll be explaining the question and its code in C++ language. So let's get started. It is saying that a conveyor belt has packages that must be shipped from one port to another within certain given days. The ith packages on the conveyor belt has a weight of weights I. Each day we load the ship with packages on conveyor belt in order given by the weights. We may not load more weight than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all packages on the conveyor belt being shipped within certain days. So let me explain what all these lines are saying. They are saying that there is a conveyor belt and certain packages are placed on this, and their weights are given. So let's say 3 4 5 6. These are four packages and their weight are written as 3 4 5 6, and there is the ship, there is another port, and we have to transfer all these packages through this ship to this port. And in each day this ship can carry certain number of packages, depends upon its capacity. If the sum of weights of these packages is within the capacity of the ship, then it can carry all the packages till its capacity. So I hope now the problem statement is clear. Now let me take this example 1 to make it more clear. In example 1, packages are given as 1 2 3 4 5 6 7 8 9 10. So these are weights of 10 packages and number of days given as 5. Here is our ship and here is our port. The question is asking to find this capacity, minimum capacity of this ship, such that it can transfer all the packages from here to here one by one. It will make one round in one day, and each day it will carry certain number of packages, and we have to determine this capacity. So as we have to determine the minimum capacity, what minimum capacity we can initially take? We can Initial value is 1, we cannot take 1. If we take 1 as capacity, then we cannot carry any other package. But if we take this value, all this is the largest weight of all the packages, and if we take this value it is larger than any other weight, so we can transfer all the packages. But here we have to determine the number of days. If number of days is this less than equal to 5, then we can say that yes, this is the minimum capacity. So let's try to find out by keeping capacity as 10. So as the capacity is 10, in one go it can take these packages as their sum of their weights is 3 to 5 plus 1 6 plus 4 10. Yes, the sum is 10, its capacity is also 10. It can carry all these packages in one go. So in day 1 it will carry 4 packages. In next day it will carry only this package, because 5 plus 6 is 11 beyond the limit of this 10. So it will carry 5 on day 2 and 6 on day 3, because 6 plus 7 is also greater than 10. So now as these values are larger, no two values can be taken together, no two packages adjacent packages can be taken together, so we can take them separately on separate days. So 7th on day 4th, and this package on day 5, this package on day 6, this package on day 7. So here we will require 7 days for transfer of all the packages, but we are given the limit as 5. So we'll try with 11 as increase in the capacity will decrease number of days required as more weight can be carried in one go. So can we take 11? We have to find out by calculating the number of days here. So as previously calculated, that we know that sum is 10, we cannot take 5, it will become 15, and now our capacity is 11. So as we have done previously, we cannot similarly here we cannot add here, we can add these two packages together for day 2, but now we cannot add any two alternate packages together. So these all these packages will be delivered in separate days, 3, 4, 5, 6. It is also going to take 6 days. So similarly we'll check for 12, 13, 14, 15. When we'll check for 15, it will come, number of days will come 5, as we can take all this in one go in day 1, and these two on next day, and 8, 9, 10 on 3rd, 4th, 5th day. So if we keep the capacity of ship as 15, we can transfer all the packages in the given time limit of 5 days. Now what will happen if I further increase the capacity of this ship to 16, 17, 18? Yes, after 15 we can, it is possible to transfer all the packages within the given limit of time, but my capacity will increase here. So I will give this as answer. This is the least possible capacity of the ship. Now let me show you for 14 that it is not even not possible for 14. So what will happen if I take capacity as 14? This all this will go one in one go in day 1, and 5 plus 6 will go next day, and 7, 8 is again 15. So it will take 3rd, 4th, 5th, 6th. 14, if I keep the capacity of the ship as 14, then also it will take 6 days. So this is the least value 15, for which I will take 5 days. So now how I am going to find this value 15? If I calculate like this for every value, then it will take linear time complexity, and this is the question of binary search. We can do it in this log s time complexity, where s is the sum of the weights of these packages. In binary search we have two limits, up lower and high. Here it is not given, but by seeing the constraint we can calculate these upper and lower limits. In constraint it is given that number of days and weights maximum can be 50,000, and number of packages can be 50,000, and weight of each package can be maximum 500 kg, 500 unit. So if I take number of packages as 50,000 and weight of each package as 500 and number of days as 1, this is the maximum value then that I can get an as answer. So this is the higher limit, that is 25 into 10 to the power 6. And if I take all these value at their low, one package and weight of 1 unit, and I have to transfer in 1 day. Then the capacity I will take is 1. Here this is a capacity because I have to transfer all the packages in day 1. Then I have to take the capacity of the ship as the weight of sum of weight of all the packages. So what, as we usually do in binary search, we eliminate certain search area in one iteration. Similarly, we will do here. This is our lower limit 1. This is our limit 10 in 25 into 10 to the power 6. So I will find mid here. That will comes between, in between somewhere, and this is capacity. I will check at this capacity mid if it is possible to transfer all the packages in given limit of time. If it is possible, then I will eliminate this area. I know that it is possible, it is also possible in this area. I will search for next minimum value that I can find here. And in other condition it can happen that it is not possible to transfer me all the packages in given limit of time. Then I will eliminate this search area, because I know if it is not possible here, then it will definitely not possible in the values, capacity values that are lower than this value. It will be somewhere here. So I will search here. I will again do the same thing. I'll find mid here, and if it is possible, then I will search here. If it is not possible, then I will search here. Why I'm searching here if it is possible? Because I want minimum value. So I know it is possible here, but it is better if I find another value for which for which it is less than this value mid, and for that value it is possible to transfer all the packages within the given time limit. The same concept I have used in solving this problem, and I will use another function to check if it is possible or not. Now let me open the code to explain what I have just told the concept. So here I am applying binary search as I have discussed. I have taken this lower limit and upper limit. Lower limit is L and upper limit is R. So this while loop will continue till this lower limit is less than equal to R, as this is what we usually do in binary search. Now I have found out mid here by doing this L plus R by 2 and here I am checking for this mid value if it is possible. Is it possible for this value to transfer all the packages? Yes. If it is possible, then I have to eliminate the right half and insert in the left half. For doing so, I am decreasing my high to mid minus 1, and in the another condition, if it is not possible, then I will search in the right half. So for doing so, here I am increasing my lower value to mid plus 1, and at last, while this while loop is over, in L I will left with least capacity of the ship. Now how this possible function is working, now let's see. Here I have passed this a vector and number of days and this mid value here. So I am checking here. I am initially defined my number of days as 1, and here I am calculating the size of length of this vector, and this ind variable is representing index, which I will be using for traversing through this vector. And here is sum will temporarily carry the sum of the weights of these packages till it is less than the current capacity. Here current capacity is the mid that is given by this binary search. So here in while loop I have placed a condition while this index is less than length, so that I will remain in the bounds of the vector weights. And here I am checking if any particular weight is greater than the capacity, current capacity. Here this is representing current capacity of the ship. If weight is greater than the current capacity, then the particular package cannot be transferred. So in this case, whole transfer is not possible, so I have returned here false. And if it is not the case, then I am checking here if I can add next package to my current current day delivery. If it comes out to be less than equal to capacity, it means that it is the weight of the packages is within limit. The next package can be added. So I have added here in the sum variable, and I have increased here index to check for the same for the next package. If if the sum and the sum which is currently storing the sum of the weights of the packages and weight of the next package become greater than the capacity of the ship, then I will break there the number of days. I will count here. I will increase the number of days by 1. I have counted 1 day because I know that now all the this is the maximum number of packages that can be transferred in 1 day. So now I have done here sum is equal to 0 so that I can calculate the sum of weights of packages for the next day. And here I am returning d less than equal to days. It means that if number of days comes out to be less than equal to the days given in the problem, then it will return true, yes, it is possible transfer. Otherwise it will if it is taking days, number of the days given in the problem, then I will return false, that transfer is not possible. So this will work. This true and false will come here, and our binary search will work accordingly. So this is the whole code, and it is working fine. Hope you understood the problem. So we'll see you all in next video. Till then, bye bye, take care, thank you.